Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to look at the concept of a force which is going to be experienced due to interaction of electric and magnetic field. And of course, we're going to use these specific illustrations which I've given on my right side for A and B in trying to, of course, understand that one. Now, we're going to consider this specific electric field which I've said, of course, using this specific symbol. So this is going to be standing for electric field in this particular discussion, whereas we're going to use this one to imply the magnetic field in that specific order. Now, in this particular case, we're going to explore the relationship between, or the relationship which is going to be developed due to the interaction between the two. And there's going to be a resultant force which we are going to look at later due to the interaction of the two, which of course we are going to refer to as a catapult force. Now, in this particular case, I've just given this specific setup on the first part on my top right of the board, whereby we're going to see later that a magnetic or magnets are going to exert a particular force on a current carrying conductor whenever we're going to have this specific interaction. In this case, we have had this specific wire, which is going to be a straight wire running through this magnetic field. Now, we're going to assume that this is going to be a three-dimensional illustration of this specific, of course, concept. I'm going to use this Cartesian coordinate system in order to assist us understand this specific setup for A. So we're going to have this specific interaction, whereby we're going to have this magnetic field running from, of course, north to south, shown using these specific arrows which I've indicated. And then we're going to, so these are going to be the magnetic field lines which are running from the north to south, given as such. And then we're going to have a current carrying conductor, which is going to be, of course, perpendicular, of course, being positioned in a perpendicular way in this specific field. So we're going to have this current running in this direction, or the current conductor, which is going to cut across this specific field in a right or a perpendicular way, given as such. And in this case, we're going to experience a force which is going to be developing due to the interaction of the two. Now, when this specific of course, source of electromotive force is going to be, of course, opened from this particular switch, or closed, this switch is going to be closed, there's going to be a flow of current in this specific, of course, conductors. And this is going to be a free suspended conductor, whereby we're going to have these specific sections acting as support, which are, of course, made up of insulated materials of either plastic or wooden ones. So in this case, this wire is free to move. And in that particular case, the current is going to flow down this one in that specific direction as shown on the board. So in this case, we're going to have the interaction between the two. And we're going to observe that in this particular case, there's going to be a particular force which is going to be experienced. And this force is going to be directed perpendicular to the magnetic field. Now, we can consider the relationship between that specific force and, of course, the current and the magnetic field by trying to look at this one. Therefore, for us to have a line that is perpendicular to the magnetic field, this is going to run across this specific axis. And therefore, we're going to have this particular force illustrated as such. So later on, we're going to see that this particular force is going to be directed in a perpendicular direction to the current and then the magnetic field, and these are going to have this particular relationship as shown using this Cartesian coordinate system. Therefore, for us, we are going to have a relationship between these three specific aspects. The first one being a magnetic field, the second one, of course, which we are going to give as such. The second one being the force which has been created due to the interaction between the two, and then we're going to consider the current in this particular case as I've, of course, mentioned. So this force is a catapult force which I've mentioned, and it's going to be experienced in such a way that this specific wire is going to be, of course, catapult in that specific direction due to the, of course, the development of that particular force. And this force direction is going to be perpendicular to the magnetic field, as I've said, and as well perpendicular to the electric field given as such. So we are going to see that the work of an English engineer by the name John Ambrose Fleming gave us a clue on identifying the direction of this specific interaction. And therefore, we are going to consider this specific input by John Ambrose. So we're going to come across these specific names, but for us to identify the various roles which they are going to play, I'm just going to mention them in a way, since we're going to have different individuals. Now there's another Fleming, suppose I had just given the name. There's another individual, Fleming, Alexander Fleming, who of course is particularly common for the discovery of penicillin. Now to differentiate that one from this specific individual, and therefore we're going to be using the specific rules like the Fleming's left-hand rule, and therefore we're going to appreciate the work of this specific engineer. Now I've given this specific illustration on the lower side of the board as B, and therefore that's going to be giving us a clue on what basically this specific engineer had given. So in this particular illustration, we're going to have this particular illustration, whereby using the two fingers of the first and the second finger, in this case and the thumb, we're going to see that these specific fingers are going to be assumed to be mutually perpendicular, as we have shown for the magnetic field, the current, and the force. And therefore, when they are mutually perpendicular to each other, with the first finger pointing in the direction of the current, so we're going to see that this particular finger is going to point in the direction of the current. And then we're going to have the second finger pointing in the direction of the magnetic field. So in this case, we're going to have this one pointing in the direction of the magnetic field. And of course, the thumb, which is going to be pointing in a direction mutually perpendicular to the two, is going to be pointing in the direction of that catapult force given as such. So this is going to form a Fleming's left-hand rule, and it's going to assist us in predicting the direction of this specific force which has been created due to the interaction of electric and magnetic field in this specific illustration. So I hope we have understood that one from this specific discussion. So I'll kindly like to request our members to be checking our description boxes for various links of other videos. Subscribe and engage us in the comment section, and also ring that notification bell to be getting various updates on our different discussions in mathematics and sciences. So that is it for now, guys. Bye, God bless you. Catch us in our next video.